is worksheet 3.2, the screencast for that. Let's take a look. I'm going to go through this a little quickly because I go over this in class, so I'm hoping this isn't the first time that you see this. But here's the main chart. It talks about the number of protons, neutrons, electrons, what the atomic mass is. First of all, let's do this. Let's cross this off. This is actually written incorrectly. It's not atomic mass. This is actually called mass number. Okay, so mass number is what we have on the far right-hand side. So now let's get back to how to do this work here. It's actually pretty easy. The atomic symbol we get off the periodic table. I'll show you how to get that in 1 second when I flip over to the periodic table. The atomic number is the same as the number of protons, which in this case, because there are no ions or things that are charged, it's the same as the number of electrons. Okay, so atomic number, protons, and electrons are all exactly the same, which means that if you have one of them, you have all of them. So I'm going to flip here. I'm going to show you we're going to go through boron, which is what letter B is for the symbol. I'm going to go through that by showing you if you have the symbol, then you automatically have the number of protons because of that 5 there. All of these elements have the atomic number, and the atomic number is the number of protons. I use a P with a plus sign to show that. Okay, so atomic number and protons, same thing. So number 5 here, and because these are always the same, number 5 there. All right, so the only thing we have left then is the actual mass number. Now, there is a difference between atomic mass and mass number. That's why I corrected that, because that is not the atomic mass. The atomic mass is like an average of all the different kinds of boron atoms, and there are different kinds of boron atoms. It's the number of neutrons that change when we have like one boron atom compared to another boron atom. Some boron atoms have 5 neutrons and some have 6. Now this boron atom that we're talking about here has 6 neutrons, which means the mass number, which is just the number of protons plus the number of neutrons. By the way, electrons is E with a minus, neutrons is N with a 0, and P with a plus for protons. When I add these two together, that is 5 plus 6, so our mass number for this is 11. Mass number is when we're talking about just one atom. Okay, if I'm talking about some average boron atom, like a whole average of them, then I'm talking about atomic mass, and that is also on the periodic table. Mass number, however, take a look at boron over here. Mass number is not on the periodic table. Only the atomic mass is on the periodic table, not the mass number. And that's because you either have to be given that information or you have to figure that out from adding the protons plus the neutrons. So protons plus neutrons equal mass number. Okay, so let's do another example, maybe 2 examples here. So atomic number is number 11. That means what I have here then is sodium, Na. So I go back here and I do my Na like that. That means 11 goes there and 11 goes there. Now if I'm looking for the number of neutrons and I have my mass number, that means that my mass number minus protons, the number of protons, equals the number of neutrons. So that means that 24 minus 11 equals, this is neutrons of 13. Okay, so sodium in this case here has 13 neutrons, because 24 minus 11 equals 13. All right, so let's keep going. So here I got protons. We'll do one more example, then we'll go to the next part. One more example, 31 for atomic number, 31 for electrons, and 31 on the periodic table is, where are we at here, is right here. 31 is gallium, Ga. So I go back here and I do gallium like this. Now, you guys know what I just said. Protons plus neutrons equals mass number. So the mass number of this then would be 68. Okay, I think we're good there. I'm going to flip ahead to this one. Oops, not that one. This one here. This one looks different but has very similar information. So let me go through and show you which parts are the same and which parts are, there we go, good. So just as we had before, protons are the same. Electrons are the same for now because there's no ions for this. And then atomic number is the same. Now here's another part I'm going to add to that. The number of nucleons, that's not right. Let me get rid of that. The nuclear charge is also the same with just a plus charge in front. The nuclear charge, there's two things in the nucleus. The nucleus has protons and it has neutrons. Neutrons have no charge, which means the only thing with a charge are the protons. So nuclear charge and atomic number are the same. The only difference is that the nuclear charge gets a plus sign in front of it. So I can do 44 for the electrons, I can do 44 for protons, 44 for atomic number. Okay, so these two are equal to each other. Now let me show you some other things that are also the same. For the highlighter here, I can highlight, notice that we have the mass number. This is something that we've talked about before in the last one. Mass number and the number of nucleons are the same. Remember, there are three parts to an atom: protons, neutrons, and electrons. The protons and neutrons each have a mass of 1, and the electrons basically have a mass of 0 because it's literally one, like 1/2000th of the mass. So we just don't consider electrons to have mass at all, and that helps with our calculating. So if the mass of our atom is 102 for mass number, then our number of nucleons is going to be the same at 102. Okay, so 102. Now we know that last thing we're looking for here are neutrons, and the neutrons, just like they were before, is the mass minus the number of protons. And that means 102 minus 44, which gives us 58. Okay, so 58 neutrons. Now over here, the nuclear diagram, that N is for neutrons, that P is for protons. I just simply write the number of neutrons, number of protons. My element symbol for this, if I go back to number 44 is this one right here. That's Ru, ruthium, or ruthium, like that. Okay, let's do another example, just so that we get used to this. Let's do one where we're given letter C, where we're given the symbol. So the symbol is Mn. So the first thing I do is go back to my periodic table. Mn is number 25, so I can go 25. Now check this out. I can do 25, where am I at here? Mn. I can do 25 for protons. I can do 25 for electrons. I can do 25 for atomic number. I can do 25 or a plus 25 for nuclear charge. Excellent. Here I can do 25 for the number of protons. Okay, now let's get back to here. We're given the mass number of 56. 56 minus 25, like this, gives me 31 neutrons. I can do 31 neutrons here, like that. Okay, and then that, where are we at here? 56 and number of nucleons. Anything that's in the nucleus is a nucleon, and that would be the number of protons and number of neutrons, which means it's the same as the mass number. So that's it. Well, that was easy. Okay, I want to show you one more thing. I don't think I need to explain any other. Nope, looks good. So you see these questions here. These are directly from the Ed Puzzle. I'm not going to redo the Ed Puzzle. I want you to use that stuff. So let's take a look at what you see here. This right here is the Rn with 226 and 88. This right here is the atomic, let me use a capital A for that, the atomic number, which you guys know as the number of protons. And this right here is the mass number, which you guys know as the number of protons plus the number of neutrons. If I have the number of protons plus the number of neutrons, and I have the number of protons down below, that means if I subtract it all, then these two numbers, that will give me the number, bonehead, of neutrons. So if you ever want to know the number of neutrons when you have what's called, this is called, by the way, a nuclear symbol. And it gives you a nuclear symbol. It says, what's the number of neutrons for this atom? Nuclear symbols are for one atom because it's the mass number, and mass numbers are for just one atom. Then I would subtract the 2 here, and what would that be? That would be 138 neutrons, okay? And that's how you would do that. So if you have the symbol for all of these, then you also have the number, the atomic number. So you may see a nuclear symbol that only has the mass number at top because Cl is number 17 for the atomic number, K is the number 19, Ar is the number 18, and calcium is the number 20. Okay? So that's how you would get these. You just look at the symbol, and that tells you what the atomic number is for all of them. And that's how you do that. Okay, good luck. I hope you do well.